Good morning, everyone. I hope everyone can hear me. You could see a chat window. You just type in whether you are able to hear me or not. All right. Can you see the screen as well? Just let me know. Okay, great. You are muted, Sunil, because if you have any queries, you can type in into the chat while the session is going on, or else you can unmute yourself and then you can ask your queries. All right, so that we don't get much disturbance, so that's why you please unmute, just please mute yourself. All right. Okay, so hello everyone. This is Khushbu on this side, your trainer for Internet of Things. Hope you all having great time. Today is the first day of our session, and I really hope you all are so excited for this training on Internet of Things. All right. Before moving further, I would like to give a crisp introduction about myself. I have been into training around 6 to 7 years, online as well as offline on different technologies. And technology always fascinates me, and today's technology is Internet of Things. So I chose it as my favorite technology for today. Before moving further, let's have a look on what are we going to cover in the training. Okay, first we will discuss on what is IoT, its need, why IoT came into existence. Then we'll have a look on what the researchers Gartner and McKinsey have to say about IoT market, and which are the big huge companies that are investing into IoT. Further, we will look upon the different challenges that exist, like interoperability between devices, scalability in addressing an infrastructure, routing and scalability, and different security aspects that are related with IoT. Next, we will discuss the different IoT use cases like the smart home, the wearable, self-driving cars, smart city, healthcare, and the other different use cases that are related with IoT. We'll be discussing that. Next, we will understand each layer on IoT architecture, physical layer, communication layer, cloud platform layer, application layer. Coming to the hardware part, you'll get an in-depth knowledge on all the sensors, the applications of the different sensors. Also, we will talk about the different development boards like Arduino, Intel Galileo, Raspberry Pi, etc. And then we'll have a look upon the technical details and usage of each communication technology as well as communication protocols. The next module is about IoT cloud platform, where we'll talk about the different device management, connection management, communication management, IoT tooling, rules engine, the standards that we need to follow for communication, analytics that takes place on the cloud platform, reporting, how reports are being generated on cloud platform. Next, we'll have a deep understanding of different cloud platform vendors like Exida, DeviceWise, Caveats, Exitely. So we'll have a look on few of these IoT platform vendors. Now getting into more details about the features of Caveats platform, how we can connect our devices, how we can send data, how we can view our data on the cloud platform, Caveats cloud platform, how we can create different alerts with the help of listeners. So we'll be covering details of the Carrier's cloud platform. That's where we are going to do our practical sessions on Carrier's cloud platform. And the last module consists of the need for security for IoT applications, the different security threats on physical, embedded, as well as platform related security threats, then mitigations of such security threats. So we'll discuss each one of them in detail. And the hands-on sessions comprise of playing with the Arduino Uno and different sensors, having connectivity with internet using Ethernet Shield, connecting and sending data to the cloud platform. Plus, we'll also be demonstrating the implementation of temperature monitoring system. So this was about what all course content we are going to cover for IoT training. Okay, so you all must be able to see this image. What this image tells that this is an image of Internet of Things, the world of Internet of Things, and it comprises of people, objects, big data analytics, end devices, businesses, consumers, networks, etc. So here we all are familiar with the word Internet. Alright, so what is Internet? That is the Internet of people, like where we share our snaps, audios, documents, videos on the different social networking sites like Facebook, Twitter, YouTube. So Internet is being created by people, for people, and it's all about people. The Internet is like a digital fabric that is woven into the life of all of us in one or the other way. So the Internet of People has changed the world in past, and now there is a new Internet emerging which promises to change the world again. And this new Internet is nothing else but Internet of Things, wherein we are not connecting people, we are connecting things. Now imagine things are communicating with each other. Like in Internet of People, we have people communicating with each other. Now how people communicate with each other? Through speaking, hearing, like people have senses like taste, smell, touch, sight. Alright, so now if things are given the ability to sense, control, touch and communicate accordingly with the other things, then we can say it becomes the Internet of Things. So in Internet of Things, we have things communicating with each other if we give them the ability to sense, control, touch, communicate, listen. So this what becomes the Internet of Things. Well, Internet of Things is the network of physical objects or things that are embedded with electronics, software, sensors and connectivity to enable it to achieve greater value and service by exchanging data. We can gather data, we can analyze those data that comes to Internet with the help of the things. We can distribute those data and turn it into a form of information or knowledge. In this context, IoT becomes immensely important, wherein we are gathering data from the different things onto the Internet, and then on those data we are doing analysis to get a knowledge, to get an information. So this is how IoT ecosystem works. Now IoT ecosystem means here I am talking about the world that is blanketed with millions of sensors. Now these sensors are taking information from the real objects that run into our world, uploading those data to the Internet. The technology that is marking your every move with these sensors and changes that are happening into your surroundings. So now for example, you are entering into your room, which has a sensor inbuilt for climate, music, lighting or decor. So the room will know how your day was in the office based on the calendar up on your phone, and the biosensors that detects the stress via blood pressure and heart rate Your music system will make the soft and soothing music rather than your suggested rock music according to your mood. So, and the climate sensor will come to know from your clothes and the outside sensor about the surroundings, and accordingly it will adjust the temperature inside the room. So this is how IoT is going to comfort your life at your home. Now, when you are walking to the refrigerator, it will not only tell you what all stuffs are present into it, but also it can let you know what you can make out of it, which is good for your mood right now, your activity level, even your weight loss. And on the software side, uh, all these things are connected to the algorithms. These algorithms predicts what you exactly want even before you know what you wanted. So this is how IoT is getting more and more comfort to your life, to your surroundings. Now these are here are listed few of the benefits of why do we need IoT. The first is convenience. IoT makes your home appliances more responsive and self-aware. Right, one more example like a microwave getting switched on and off on its own. All right, your bedroom temperature sets right for you. So these were some of the examples of how IoT is going to become a convenience part for your life in your home or in your office, wherever you want a comfort zone for yourself. Next is smart decision making. Now, whether you are running out of your grocery at home or the inventories in your company, you can monitor just anything with the help of IoT. You can easily collect all the information and decide on what you need to purchase and stock on. So, with the help of self-analyzing devices, you can take decisions beforehand and save yourself from the stockouts, delays, or even wastages. So, this is how it helps in decision making. Next is cost saving. Customers and organizations can benefit from improved asset utilization like smart meters that eliminate manual meter reading, and service improvements like remote monitoring of a patient in a clinic, clinic settings, or monitoring of a particular system or a particular asset, so that we can have a look on what all maintenance are required for the particular machine or the asset. So this is how before it get worse, before it get worst, we can save the time, we can save the cost as well before maintaining it. All right. So this was about how we can reduce the cost. Next is improved asset utilization. So with the improved tracking of assets like the machinery, equipments and tools, with the help of sensors and connectivity, businesses can benefit from real-time insights and visibility into their assets and supply chain. Next is remote control assets. Now, the cutting edge technology of IoT enables your smartphones and tablets to have full control over the other devices regardless of their brand or protocol on which they are running. So till now you have been using your gadgets for communication and entertainment, but now they can even manage and monitor just any device from anywhere. It may be a toaster, a garage door, a fridge, or anything else. So IoT reduces the complexity of managing them all from different places and all in one way to take the control through your smartphones, through your tablets, through your laptops. So this is how you can remotely control and have a look on your different devices. Better living. Now, as a massive network of devices, IoT promises to improve your living standards from inside your home to everywhere you go. New functionalities, self-operating ways, higher productivity, and timely solutions offered by IoT makes your day-to-day life smarter and more modernized and more convenient. And the most important part that comes is safety and security. IoT can also be used to ensure situational awareness and safety of people. a lot of data in form of clippings can be collected through video cameras installed at various places. We can watch the incidents that are related to them. We can catch hold of the criminals. So this is how we can use IoT for safety purposes and security purposes. But who is going to be benefited by this? The big businessmen, tech clients, geeks like us, and everybody wants to live a better life. So technology that is inherent into IoT is to sense and communicate that acquires data. So everybody must be so wanting to have a good, convenient life, a good, better life, to have technologies around them so that they can have a secure and safe life. They can have cost saving. They can have remote access of all the devices that they want to monitor. So this is how IoT is going to be helpful for us in different ways. Let's have a look on the history of IoT.
Excuse me, I have a question. I'm not sure about the protocol. I'm just asking. Would you be taking questions after every few slides, or do we go on answer
Typing
questions?
the question. May I know who am I talking to?
Yeah, this is Sunil.
Okay, so you can just type in your question in chat, and meanwhile I'll solve your query and give you answer.
Okay,
All right.
the reason I'm asking is sometimes it is easier to ask the question for some interactivity than just typing it in. But if that is the protocol, I'm gonna type it in. Sometimes the question might be long to type, so.
Okay, if that is the case, you can directly ask me the question. You just let me know so that I'll unmute you, and then I'll ask you to ask me a question. All right, so that we don't have a break between the sessions. Is that fine?
Sounds good. Yeah, I'll just share, type it in saying I have a question whenever I do. So, okay, thank you.
No problem. No problem. Thank you. Yeah. Okay, so we were discussing about the history of IoT. In 1999, Kevin Aston, the executive director of Auto ID Center, coined the term Internet of Things. Then in 2000, LG announced world's first connected refrigerator. In 2002, uh, the Forbes stated that the stores can have eyes. Now they can get the brains. You can come to know what you want to buy and from where you can buy it. In 2005, Italy developed Arduino, that is a single board microcontroller based on Atmega 8. In 2008, IPSO Alliance was formed to promote IP connections across network for smart devices. In 2010, the Google debuted a self-driving vehicle project, plus Bluetooth Low Energy Protocol, that is a technology protocol, communication protocol was introduced in 2010. In 2011, IPv6 is launched. Okay, Sunil has a question. Sunil is asking, good to know all the type of sensors and examples that you mentioned, but how far in reality everything being used? Or are we talking about only potentials? Sunil will discuss each of the sensors plus what are the applications that are related with the sensors. We are also going to do practical sessions on them. So at that time, at that moment of time, you can definitely come to know in detail about each sensors. IoT kit has been dispatched from here. I hope you will get it this week. Okay, Sunil?
Yes,
Maybe
thank you.
this week you get the kit. It takes around 10 days, all right, for I guess delivering. So you'll get it. Okay. So in 2013, Google Glass was released to the developers. In 2014, chip makers, Intel, and other high-tech firms set up a competing group for All Seen Alliance with an open interconnect consortium that also we are going to discuss. So this was the history of IoT. Let's move on to a few applications of IoT. Like applications of IoT are limitless, and and, and are changing the way we work, we live, by saving time and resources, opening new opportunities for growth, innovation, and knowledge creation. In this we have variables. So variables, I hope many of you must be using these fitness bands, wherein they can track your need, how much steps you have walked, your sleeping track, heart rate monitoring, smart alarms. Smart homes are all the convenience that you want in your home. So that what we already discussed about the refrigerators, the oven, the air conditions. So all this comes under smart homes. Self-driving cars. So self-driving cars are capable of sensing its environment and navigating without a human input. Smart cities. A smart city uses digital technology or information and communication technologies to enhance quality and performance of urban services so that we can reduce cost and resource consumption and to engage more efficiently and actively with different citizens. So with smart city we can have traffic and transport monitoring, we can have smart parking, pollution monitoring, then energy management, smart healthcare, video surveillance, communication systems, smart retail, smart supply chain management. So healthcare, that is smart healthcare, that also comes under smart city. So these are the few of the applications of IoT that are currently being used and many companies are investing into it. You can see the images of wearables, self-driving cars, smart cities. Okay, this is the hype cycle. You can see the Internet of Things. This hype cycle has been, you know, given by Gartner. So, Internet of Things has been identified as one of the peak emerging technology in IT, as noted in this hype cycle that has been given by Gartner. So a hype cycle is a way to represent, the emergence, adoption, maturity, and impact on applications of specific technology. It has been forecasted that IoT will take around 5 to 10 years for market adoption. McKinsey has to say that analysts have predicted that the installed base for Internet of Things devices will grow from around 10 billion connected devices in 2013 to as many as 30 billion devices, and right now it has been predicted that it can go up to 48 billion devices by 2020. So currently we have 10 billions of devices connected to internet, but by 2020 there will be 50 billion objects connected to the internet. So there will be 7.6 billion people alive at that moment of time. So we can predict that 6.6 object will be connected to a particular person. So this is how we are going to be so dependent on our objects on IoT. So we'll be having around 6.6 objects connected to a particular person. So you can see a vast difference in 2013 or when we talk about 2020. Next we'll discuss the top investments. So India Smart Cities project has invested around $2 trillion. The Indian government has announced a package of $2 trillion to connect 100 cities across the country. The Intel was said to be discussing the purchase of chipmaker Ultra for $10.4 billion. So Intel changed its reporting structure to report on 5 separate lines of business. So this is how Intel is investing in IoT. Google spent $3.2 billion for network thermostat makers Nest Labs. So Nest thermostats are capable of learning user behavior and working out whether a building is occupied or not using temperature, humidity, activity, and light sensor. IBM announced $3 billion for a business unit designed to help clients and ecosystem partners build IoT solutions. So these are the few big investments of companies for IoT. Next we have IoT challenges. IoT is shaping human life with greater connectivity and ultimate functionality through networking to internet. So with all these promises and potentials, IoT still has to resolve four major issues and challenges, that is interoperability, scalability, routing and forwarding, and security. So let's discuss interoperability. Interoperability is possible only when technology giants such as Google, Microsoft, Cisco, Intel, etc. come together and develop a cross-industry open source project that provides a universal software framework for IoT. Now, the IoT ecosystem requires interoperability to create, seamless programming for every device, for every sensor. So there should not be uh, any security or any protection for a particular brand or any or a brand or a type of the manufacturer. So in interoperability, we can have the big giants coming together. They can have a cross-industry open source project so that we can connect to different devices regardless of their brands and the type of the device or the manufacturing of the device. So Allsyn Alliance, Open Interconnect Consortium, and Thread are some of the collaborative open source efforts by technology giants to enable all the things in the Internet of Things to work together. Devices from different OEMs, that is original equipment manufacturers, should be able to interconnect and share their information regardless of their brands. And there should be a standard communication protocol for devices in IoT applications. So these are the few challenges that we could face for interoperability, and there are also solutions that different alliances have been collaborated to solve this standard communication protocol. Next is scalability. Researchers predict that IoT will enable billions of devices communicate over internet, which will also bring in challenges of scalability. In scalability, we have addressing challenge, infrastructure, and database. So for addressing, now imagine each device will have its own IP address in IoT. So for IP addresses, IPv6, which is having only 32-bit address field, it has a provision for only 4 billion IP addresses, which is almost exhausted now. So IPv6 solves this problem of addressing with its 128-bit address field, which is quite enormous, but the acceptance and usage of IPv6 has been slow. So therefore, technology providers should start adopting IPv6 to overcome this addressing issue that will soon going to arise when we are going to connect billions of devices for IoT. Now in infrastructure, we have a network infrastructure that needs to be scaled up to handle massive load of network connections from different devices, billions of devices that are going to join the IoT ecosystem. So infrastructure problem will be arise in future, so we need to tackle it with different network protocols and different connectivity issues. Database. Now all these, imagine billions of devices sending data. So where are these data going to be stored? So the Internet of Things, is comprised of infinite arrays of devices and data sources that need to communicate with each other. So these devices in real time will create a flood of data, and these data needs to be stored at one place. It needs to be analyzed. It needs to convert itself, these data, into information. So database is going to be a very important issue for IoT, wherein we are going to store, analyze, and process data that are coming from different sources, from different devices, that is billions of devices. Now here a single car can generate data. Imagine this one single car can generate how many types of data from different sensors that are inbuilt into the car. That is lane keeping system, autopilot, in-car video camera to record accident incidents, night vision device, lane changing warning, front and rear end collision alarm warning. So through brakes, through suspension, through engine. So for imagine this one car is going to send so much data to the cloud, to the network, to the internet. So if there are millions of such cars available into our world, so how much data is going to be generated? So we need to manage those data. Now the second challenge is routing and forwarding. Embedded devices used in such low power and lossy network applications are always severely constrained in terms of available power. Now, all these devices that we are going to use for Internet of Things, they are associated with power, but many a times we are not able to give them battery life or give them continuous power. So how are they going to forward the data? So therefore, energy efficient routing of data becomes critical to any long-term sustainable solution. So the routing protocol must be able to support a full deployment of a few hundred to tens of thousands of sensor nodes without deteriorating selected performance parameters uh, for configuration thresholds. So there should be a fixed protocol, or there should be devices into our system so that it can send data, it can forward data for a long distance of time. Security. Now, the IoT does not come without its challenges, and when we are connecting more and more data, we are having more and more challenges. Some of the security threats are listed below, that is data security, physical security, security of devices, regulation, privacy, encryption, authentication. We are going to discuss all the security threats that are related to the physical, embedded, the different platforms, and also the mitigations of all the securities. Now, this is an example of a smart meter. Smart meter is one which is able to send energy usage data to the utility operators or for dynamic billing or real-time power grid optimization, that must be able to protect that information from any unauthorized usage or disclosure. So the information that power usage has dropped could indicate that a home is empty, so making it an ideal target for a burglar. So this is how a smart meter security threat is on a smart meter, which could hamper a particular family or a home. Now the security must be addressed throughout the device lifecycle, from the initial design to the operational environment. When a device is first powered, the authenticity and integrity of the software on that device is verified using cryptographically generated digital signatures. So we need a secure booting at the time of when we are first powering our devices. So that first issue, when security life cycle, is the secure booting, wherein we need to have a cryptographically generated digital signature when we are booting our device for the first time. Next is access control. Now, mandatory or role-based access controls built into the operating system, which may limit the privileges of the device components and applications, so they can be accessed only by those resources which resources needs to access them. So this is the second part. Okay, when I'm saying devices, I'm referring to anything that is going to send data. So this thing will be connected to a particular sensor. All right. So when we are going to discuss the IoT architecture, this will clear your doubt that how IoT ecosystem is going to work. Okay. Okay. So we were on access control. Access control is very important so that any resource cannot have access to everything. So there should be mandatory or role-based access control built into our operating system for a particular device. device authentication. When the device is plugged into the network, it should authenticate itself prior to receiving or transmitting data. Alright, firewall and IPS issue. Now the device also needs a firewall or a deep packet inspection capability to control traffic that is destined to terminate at the device. Many a times DOS attack, that is denial of service attack, can hamper your device. So there should be a firewall, to protect, to cover your device. Then updates and patching. Software updates and security patches must be delivered in a way that conserves the limited bandwidth and intermittent connectivity of an embedded device and absolutely eliminates the possibility of compromising functional safety. So these updates and patches needs to be monitored while we are updating our software or our system or a particular device. So this may also be attacked in case of, if we go in case of security aspects. Next we have IoT architecture. Okay, alright, so here in this image you can see the different applications, how IoT is affecting environment, how we can give identity, how we can track our device. The device can be anything or any people or animal, anything that where you want to get data, where you want to monitor, wherein you want periodic update from that particular thing or device or a room. It can be anything. Alright, so for home automation system also you saw it can be any electronic devices or anything, your table, chair, anything in your home. Connected cars, personalized insurance, energy grid, social and local, building management, logistics and shipping, healthcare. Now, but what is the need for an IoT architecture? Why we need IoT architecture? To connect these physical world, to a web using wide range of technologies, we need IoT architecture. To connect the world's applications, data and devices, there should be a particular format or a prototype so that we can connect our devices and we can send it to the internet. We can store data and accordingly we can do analytics on it and send the information in the form of message or email or alert or alarm. So for all this, for 50 billion connected devices, we need an architecture. So architecture will provide a reference on how to connect billions of devices and sensors to create new and innovative applications. Here it illustrates on how various technologies relate to each other and communicate the scalability, modularity and configuration of IoT deployment in different scenarios. Here it also represents a conceptual layout for a connected smart system that consists of different technologies, different things and different platforms. So here where we need IoT architecture, wherein we can have a standard format, how we can send data, how we can receive the notification, a cycle for IoT ecosystem. So next we are going to discuss what can be the four major layers that made this architecture. So the IoT architecture is made up of four different layers: physical layer, communication layer, cloud platform layer, and application layer. Now what can be into physical layer? What you think could be into this physical layer? See, the physical layer is nothing but it consists of the different things, the devices, sensors that we are connecting with those devices or people. You imagine anything you want to have data on can be connected to sensors, and according to that particular thing, like the air condition, in air condition we can connect sensor like temperature sensor or humidity sensor. If you want to have a look on whether you have watered your plants, so you can have one moisture sensor into your pot, into your plant pot, to check whether you periodically water your plants. So if you have missed a week, then your plant will send you a message into your mobile that, oh, you have forgotten me, or you have forgotten to water me. So this is how you can have anything as a device in IoT. You can connect sensor to it, and these sensors in the form will send data to the gateway, to the cloud. A sensor is a transducer, whose purpose is to sniff a wide variety of information ranging from location, it may be a weather or environment condition, grid parameter, movement on assembly lines, jet engine maintenance data. It can be any health related data. So the sensors in IoT are called as nodes that will collect information and send it to the outside world through the communication protocols like Bluetooth low energy, means different protocols, Zigbee, Z-Wave, Wi-Fi. All this with the help of all these communication protocols, these sensors will send data to the gateways, and the gateways will act as a bridge between the IoT objects. There are different types of sensors. We are going to discuss each sensor. Well, the sensor depends on your application, which object you need to connect to it. So there are different types of sensors for different location, for different objects. These sensors have their own properties. So knowing its property, you can use those sensors. So we'll discuss each sensors in detail. We're also going to discuss the different communication protocols and technologies, where to use and when to use, for which range. We are going to discuss each communication technologies in detail. So first, sensor will send data to the gateway. A gateway will act as a bridge between IoT objects and the internet. So the gateways can connect to the IoT devices that communicate via a specific protocol, that is a communication protocol. It can store and parse the information. On the cloud platform, the cloud computing is the only platform that will support such massive and unpredictable data, and it will do analysis on it with the help of big data solutions, and it will also gain insights and patterns of usage and behavior of different machines and humans. So this business intelligence in turn allows us to predict forthcoming growth in data demand and deploy additional resources accordingly. So once these patterns are analyzed, so if any pattern is found irrelevant, then accordingly the information will be sent to the user to control or monitor the particular device. Okay, so here where it comes the application layer. So imagine in physical layer we have all the sensors, the devices that are going to communicate, that are going to send data to the cloud. In communication layer, we are talking about all the different communication technologies and protocols that are related for sending data. Next, we have cloud platform. In cloud platform will between all the analysis, data storage, sending and receiving of data, notification, alarm system, everything will be done on cloud platform. An application layer consists of your own application like weather forecasting or location forecasting, monitoring, getting getting temperature notification. So that comes under your application, wherein you will get the notification for in the form of a message, an email, or periodic updation on your website or something. So on your application in your mobile. So application layer consists of all those applications where the user wants the information for a particular device. Alright, so this is how the 4 layers works in IoT architecture, starting from physical layer to application layer. Now this can also be reversed, wherein in application layer a user wants to make few changes, or if the user wants to control, then he can send that message to the cloud platform, wherein a particular rule has been designed for particular input, and through the help of communication protocols it will be sent to the physical layer. So the physical layer, the opposite of sensor is actuators. So the actuators will actuate that particular device, and it will do the changes like on and off of the microwave oven or the light switch in your home. So it can be anything wherein it will control your particular device or a person or a machine, switching on and off to a particular machine. So this is how it becomes a two-way communication from physical layer to application and application layer to physical layer. Now here, this is a high-level IoT architecture. You can see here the physical layer comprises of all the things and devices, the microcontroller, processor, the different things. In communication layer, we have the different communication technologies and protocols: HTTP, MQTT, Wi-Fi, Zigbee, Z-Wave, Bluetooth, low energy. The different technologies that we are definitely going to discuss, and you will have brief knowledge on all the technologies. Then we have cloud platform layer, wherein we are going to store data, we are going to do analytics on it, we are going to send notification in the form of information to the user, to the application layer. So here in application layer, we have web or mobile apps. So any application that is installed on your phone, you can have notification onto it, or you can have notification through email or message. Alright, so the physical layer is at the lowest layer. Okay, so that is made up of all the objects, the sensors that are going to interconnect to the physical and digital world, allowing real-time information to be collected. And there are different types of sensors for different purposes. So these sensors have the capability of taking measurements such as temperature, air quality, movement, for electricity. So in some cases there may have a high degree of memory, so enabling them to have a record of certain number of measurements. A sensor can measure any physical property and convert it into a signal that can be understood by an instrument. Okay. This is a breakdown for the IoT stack. Here you can see in application layer, we have all the different applications for which we are getting information or data, like environmental change, energy, asset management, fleet management, transportation, supply chain, healthcare, people tracking, retail, surveillance. In cloud platform, you can see things and device management. So it will manage the thing, the data of the thing, it will store data, it will track the things, it will have visual asset display, provisioning and remote monitoring, asset grouping, then M2M application development, different IDE tools, debugging, wherein we can write our own code to get alert or a listener from the cloud platform. So here in application development, we can build our own application with the help of the different application program APIs, that is application program interfaces of cloud platform. Analytics and reporting, when we are going to store data in the form of big data, then we can drag and drop report data, we can generate reports, we can have analytics on it. Right? Cloud middleware core features, wherein we can have scalability, data store management, then it supports security standards, we can have different authentication, encryption, security standards. Then M2M rule engine we can have, where we have a fixed business rules to trigger for a particular device, complex event processing. Then SIM management, where we have mobile network operating integration, rate plan management. So all this comes under cloud platform sorry layer. In cloud communication layer and device layer, we have different communication protocols, right? Different communication technologies and protocols. Then in physical device layer, we have the different gateways and sensors which will be sending data to the cloud with the help of communication layer and to the application layer. All right. If anyone have any doubt for in this IoT architecture, please let me know, because this is the base of IoT to understand the IoT architecture. Don't go into the
Hi.
details. Yeah, tell me.
Sorry, missed the part where the application layer is connected back to the physical layer. Can you explain briefly?
Sorry, I'm sorry, I'm not getting you.
Okay, I missed
Which,
the part where you said the application layer is connected back to the physical layer through some tools or something. Not sure.
yeah, that means the reverse communication from application layer to physical layer, right? That's what you're asking.
Right.
Yeah. So like when we are going from physical layer to application layer, we are sending data through our sensors to the cloud platform with the help of communication technologies to the application. All right. So where cloud platform will do the different analytics, and it will generate information that is essential for a user to know. So it will be sent to the application layer. Now, once you have got a notification that okay, you forgot to switch off your microwave. All right, so you will send a message to the cloud platform. Okay, so the cloud platform will have a trigger rule that will be a fixed coding, or we can say a fixed program, when it will send it to the communication through communication layer, it will send it to the physical layer. So here, in place of sensors, we are having actuators. So actuators will do the opposite of sensors. Actuators will, actuate a particular device. It will switch off your microwave oven, your fan, or it will switch off a particular machine. So this is how you can send particular information from application layer, and it will be acted to the physical layer.
But now the actuators can do binary operations like on and off, or can they do something else as well?
No, they can do anything that depends on your application. So
Okay.
once we go deep into the different layers, I'll explain you how a sensor, how actuator, or how these communication technologies, what will be the part of each one of them. I was just asking that, are you aware, means you got a whole idea about how IoT architecture is going to work. I'm going to, go into deep details of each one of these layers, but I was just asking that now, are you getting my point that how actually IoT architecture works?
Yes.
Okay, great. Okay, Asif has a question. What can be a gateway firmware like? See, a gateway can be anything. It can be any controller, or any processor that can have internet connectivity, which can send data. So a sensor will be connected to a gateway, and these gateways should have that capability, which can send data to the internet. All right, we'll discuss each of these gateways and nodes in detail. All right, anyone else having any doubt, you can please type in your question, or you can let me know so that I can unmute you. All right, I don't see much questions, so we'll do one thing. We'll have 10 to 15 minutes of quick break, and we'll get back. All right. Hello. So, can we start? Okay, just for your understanding, I have quickly prepared one image which will describe you know, your whole confusion will get solved. So here, first thing that is a physical layer is the things, and with it we have sensor. So they will be sending the data to the gateway, and these gateways can be a microcontroller or a processor which should be internet enabled, which should have the capability to send data to the cloud. So the sensor data will be sent to the gateway, and the gateway will send data to the cloud platform. So cloud will do the data storage, analytics, reporting, uh, you know, sending, having programming codes for sending those alerts to the application layer. The application layer here will get a notification or will get an alarm in the form of a message or through email. So this is how it is going to work. So things and sensors becomes a node, and this node will send data to the gateway. The gateway should be internet enabled, which will send data to the cloud platform. Okay, even the gateway can be your mobile phone. Even you won't imagine that your mobile phone has different types of sensors which sends data. So even your mobile phone can be used in the form of a gateway for sending data to the cloud. Okay, so even your mobile phone can be a smartphone can be used in the in place of gateway. Okay, and so next, now we'll have a look on the different layers in detail. So the first is the physical layer, that is we have, it's the lowest layer of IoT architecture, wherein we have smart objects integrated with sensors. These sensors enable the interconnection of the physical and digital world, allowing real-time information to be collected and processed. These are various types of sensors, as we discussed, on in the form of temperature measuring, air quality measurement, movement, electricity, light, sound wave. So a sensor can measure a physical property, and it can convert it into a signal that can be understood by any instrument. So here we have group of sensors based on their applications. Environment sensors, when we can have temperature sensor, humidity sensor, we can have moisture sensor, we can have sensors based on the environment pollution. Body sensors, which will detect our heartbeat. uh, our for diabetes we can have different sensors. For home appliances, we for particular home appliance, for a particular electronic appliance in our home, we have fixed sensors for it, vehicle telematic sensor, ultrasonic sensors. So based on the application we can choose our own sensor. Now here is an example how many sensors can be built into a human body. So a patient position sensor, where we are using accelerometer, which will detect the position of the patient. Pulse and oxygen in blood sensor, body temperature sensor, galvanic skin response sensor, e-health sensor shield for Arduino and Raspberry Pi, electrocardiogram sensor, airflow sensors. So imagine in our body we can use these many, actually more number of sensors to have a health report that will be sent to the doctor. So these sensors can be built into our body, or it can be manually tested. So for different application we have different types of sensors. Now most sensors require connectivity to the sensor aggregators that we call gateways. So here the figure shows the different development boards like Arduino, Raspberry Pi, electric ink, which can be used as end-node microcontrollers or gateway devices that is based on their processing capabilities. So based on our application, we can choose one of the gateway which will help us send sensor data to the cloud. So these gateways should be internet enabled gateways. if we are using it for sending it. So we have Arduino, we have Raspberry Pi, BeagleBone. So this can be in the form of a local area network such as Ethernet and Wi-Fi connections, personal area networks such as Zigbee, Bluetooth. So depending on the range, we can choose the communication protocol. We can choose, depending on the processing capabilities for our application, we can choose the particular gateway. So once you will have detailed technical knowledge on all these microcontrollers, processors, as well as the different the communication technologies, it becomes very easy for you to choose which protocol you want to choose for your application, which gateway you want to choose for your application, which sensor you want to choose for your application. The same way, there are different types of, they are also a type of microcontrollers in the market. Yes, they are boards. They are also boards. That depending on now, each company is having their own cloud platform. Is having their own platform. They want their own, board, development board for a particular cloud platform. For example, Xively has its own board. So it depends. Due to IoT, it's getting vast. Every company is investing so much, and every vendor wants its own investment for the development board, for their own having their own cloud platform. So what I was talking about, that for an application, so once you will have a knowledge on all what are different sensors, what are different communication protocols, and what are different development boards, plus what are different cloud platforms. So it becomes very easy for you to choose the particular sensor for your application, to choose particular microcontroller, to choose a particular cloud platform for your application. Alright, so once you have knowledge of each one of them, you can choose the particular thing for your application. So next is a communication layer. This layer consists of massive volume of data which will be produced by the tiny sensors, and this requires a robust and high performance wired or wireless network infrastructure as a transport medium. So with demand needed to serve a wider range of IoT services and applications such as high-speed transactional services, context-aware applications, etc., multiple networks with various technologies and access protocols are needed to work with each other in a heterogeneous configuration. So communication layers consist of all these communication technologies and protocols. These networks can be in the form of a private network, it can be a public or a hybrid model, and are built to support the communication requirements for latency, for the bandwidth, or for security. So the communication layer can be split into two. One is the device level transport layer and cloud level transport layer. Now the device level transport layer includes personal area network protocols, that is the Zigbee, Wi-Fi, Bluetooth Low Energy, Z-Wave. Okay, and for cloud level transport layer, it consists of HTTP, HTTPS, MQTT, CoAP protocol, XMPP protocol. So depending on your application, depending on the network that you are going to use for your application, you can choose the particular protocol. Okay. Next is cloud platform layer. Now the cloud platform layer is the management service layer, which renders the processing of information that is possible through analytics, through different security controls, process modeling, management of different devices. So the cloud platform, we can say it is a middleware on the cloud used for provisioning, monitoring the smart devices, handling of data through these devices. We can also have historic data to be stored on the cloud. All right, so all this enables with the help of Ethernet, Wi-Fi, Zigbee, Bluetooth. Different communication technologies are used to send data from these devices to cloud platform. So these platforms will collect and process data sent by smart devices for data analysis. These platforms provide support for various M2M features like data storage, device and data management, asset location, tracking, geofencing. Everything will be done on this cloud platform. Even we have different vendors for this cloud platform. So depending, as I said, depending on your application, these you can choose any of the platform. Few of the platforms are free, few of the platforms are paid because they are platform as a service. So you can pay as much you use through monthly basis or yearly basis. Okay, so cloud platform will do all this monitoring, provisioning, collecting of your data. These are the few characteristics of cloud platform. For our our application, for our own project, we are going to use Carrier's cloud platform. Okay, so in detail we will have a look on Carrier's cloud platform later. I'll also this is Carrier's cloud platform is free of cost, so you just need to create your account and you can use the different services of this cloud platform, that is Carrier's cloud platform. Okay, so for a particular cloud platform, it should support the following characteristics. So that is things or asset management. It should have a good management, a hold on the different data of our things. It can manage more than one devices from different locations. Then connection and communication management should also be having good support for the cloud. SIM management and wireless services. If we want, we can send data to our particular phone number with the help of SIM management services, wireless services, things, map and location tracking. If we want to track our asset, then there should be the facility in the cloud platform that we can easily track our asset, or we can have a geometric location of the asset if our asset is going into the wrong direction, or if it's entering a region where it should not enter. So that should all this facility should also be there in the cloud platform. End-to-end tooling, that is machine to machine tooling, the different application development services. We can also build our own application there. We can write our programming, we can debug the program according to us. Different rules engine, support for standards, communication standards. Then analytics and reporting, M2M infrastructure. There should be a particular infrastructure wherein we can connect our devices. We can send the list, we can send the alarm or alert in the form of notification. So all these are minimum requirements, supports, minimum characteristics that should be available in a particular cloud platform. This is a list of different cloud platform vendors: Ares, Carrier, Schemato, Device Cloud, ThingWorks, DeviceWise, and maybe this is not the only list. There are even more cloud platform vendors. So depending on your application, depending on your usage, you can choose your cloud platform. The application layer. Now, there are various applications for industry sectors that can leverage on IoT, different applications for a particular user. So the applications can be verticalized ones that are specific to a particular industry sector, as well as a particular application such as fleet management, asset tracking, then monitoring, environmental tracking. So these are the applications wherein we can, based on our application, we can choose which sensors we want to use, or which platform or which gateway we want to use. Alright, so these applications are connected to user, so user will get what all information that are required by the user on its own application, in the phone or through any other notification system. These are the different IoT use cases. First is the connected car. Now maybe you must be aware about these connected cars. Like, it's a car that is equipped with internet access, and usually it's a wireless local area network. So this allows the car to share internet access with other devices, both inside as well as outside the vehicle. And often the car is also outfitted with special technologies that tap into the internet or wireless LAN, and it can provide additional benefits to the driver. For example, automatic notification of the crashes, or notification of speeding and safety alerts. So this is being found in most of the cars nowadays, this technology. Next is fleet management. Now, fleet management includes the commercial motor vehicles such as the cars, aircraft, planes, helicopter, and different ships, vans, trucks, as well as rail cars. So, fleet management can include a range of functions such as vehicle financing, vehicle maintenance, vehicle telematics, driver management, and speed management, health and safety management. So all this can be taken care under fleet management with the help of IoT. What is inventory management? Now here it refers to the inventory, the goods that are stocked for future use. So every retail chain has its own warehouse to stock the merchandise to be used when the existing stock replenishes. So inventory management refers to the storage of products at the time of crisis. So the retailer keeps a track of the stock code. So in place of retailer, we can have one or the other, smart device that is into the warehouse, which can detect whether the stock is getting, whether the products are getting out of stock. So this way we can use IoT into the inventory management system that is being used actually. Smart parking, it will be helpful for optimizing the parking space usage. It can also improve the efficiency of parking in a particular street or off street in a city. So it can also help trafficking your city flow, right? So this is how a smart parking, you will get indication into your car with the help of simple Z-Wave or Zigbee protocol installed in the point of the parking space. So easily you can detect, okay, in your car only you can have a look on where is the parking space empty. So you can do the smart parking likewise. Then water management, you can have different activity planning, development, distribution, and managing of the different water resources into your city. You can, with the help of different sensors, you can come to know how much you can have a report of the amount of water utilized or the amount of water being wasted in the different parts of the city. So this is how you can manage your water for a particular city. Then health monitoring has endless applications or use cases for IoT. It starts from the fitness band that is being used everywhere by many of them, diabetic kit that is installed into the patient's internal areas of the stomach. Then it can monitor your hand hygiene compliance to reduce the transmission of hospital acquired infections to patients. It can provide core practice functionalities needed by clinicians as well as the front office and building staff. It can analyze your protein level. It can send these data in the form of information to the big data. The big data can do the analytics and it can send these reports to the doctor, and the doctor may come to know, okay, this patient is degrading, its health is degrading, or it can come to know the diabetic level is increasing or decreasing, the sugar level is increasing or decreasing for a diabetic patient. So health monitoring has a different applications, a lot many IoT use cases. Home automation is a residential extension of building automation. So it is automation of the home, household work or household activities, the different electronic appliances, security locks on the gates, doors, and other systems to provide improved convenience, comfort, energy efficiency, and security. So home automation can be very helpful for the elderly people or for a disabled people, you know, can provide an increased quality of life for people who might otherwise require someone else to take care of them. So home automation system can be helpful. We have different use cases in home automation like this, that we can have convenience in our for our family. Alright, so anybody having any doubt till now? You want to ask any of the doubts, you can shoot on me, or you can write. Yes, Sunil, definitely all these videos will be available to you on the LMS. Just today or tomorrow, you will have a look on all these videos. Access, yes, there is. Sunil, access, I think it's for lifetime. Well, I'm not sure. Yeah, I think Umesh would be a better person to answer this, for LMS access. And yes, Asif, we have Microsoft Azure as a cloud platform. I told you, na, there are different vendors, not only that I have listed, there are more than the list, there are different vendors of cloud platform. So what suits you, you can use that cloud platform. Okay, so that's it for today. Tomorrow we'll continue this session.
Question, what are the course contents, course materials that we are going to get in terms of soft
I think,
copies?
Sunil, the course material has already been uploaded on LMS.
Oh, I see. Got it. So that is our source, right, for the contents?
Yeah,
Okay.
LMS will be the source for you for videos, for course content, for any other material or any quiz or so. LMS will be your learning management system portal when you will get everything.
Perfect.
Okay. Even if after the session, after the training, if you have any queries, you can directly mail to Umesh. He'll get in touch with me. Okay, and your queries will be solved.
Perfect. And tomorrow we're starting same time, 9 a.m., right?
Yes, definitely
Okay,
9 a.m.
IST. Perfect.
Okay. Okay, so thank you so much for your patience and listening to me. See you tomorrow.
Thank you.
Thank you, Sunil. Thank you, Asif. Have a nice day.